Okay, welcome to the math review video. Please get out your SmartPal and we're going to work on the multiplication algorithm. I know that it can be a little tricky. There's a lot of steps, so we're just going to do one problem at a time and see if we can get it straight. So the first problem we'll try is 56. Oh, sorry, I'm actually going to use a different pen here. Sorry. We'll try 56 times 43. So the first thing you can do is pause the video and give it a go yourself. Okay, so when I'm doing this, the first thing to know is that this is really the same as the area model. 56 times 43. If you think about it, if we had a rectangle here and we had split it into 50 and 6 and 40 and 3, we split the digits, right? So we do 3 times 6, we do 40 times 50, we do 3 times 50. We do each of the parts separately, and that's all we're doing in the algorithm. So we start with the ones, and in this case, in the algorithm here, and just like in the area model where we do 3 times 6 and 3 times 50, here we're going to do 3 times 6, 3 times 50. Okay? So 3 times 6 is 18, so I put the 8 here, and I carry the 10. 3 times 5 is 15. We know it's really 15 tens, and I add the 10. So I get 16 tens. So I put a 6. And then I have an extra one that I put in the hundreds. Okay. So now that the ones has taken its turn, now it's time for the 4 tens to take its turn. So just like here, where 40 is going to multiply by 6 and by 50, it's the same thing. 4 times 6 and 4 times 5. But before I get started, a couple things I want to remember. One, this isn't 4 ones, it's 4 tens. I put a 0 because I know that everything I multiply will be in the tens. Okay? And the second thing I like to do is get rid of all of the things that I carried before so I don't get confused. Okay, now 4 times 6 is 24. I know that's 24 tens, but I put the 4 here, I carry the 2. 4 times 5 is 20. I add those 2 tens, 22. So 2, I carry the 2, and that puppy just drops. Okay, now I can add them. All right. 8 plus 0 is 8. 6 plus 4 is 10. Carry the 1. 2 and 4 and 2. Okay. So 56 times 43 equals 2,408. All right. I'm going to give you another 2-digit by 2-digit problem. This time I'm not going to go over it, but I will write the problem and then just reveal the answer and see how you did. Okay. Okay, so here you go. 36 times 24. Pause the video and give it a try. Okay, in the end, you get 864. Now, remember you took turns. You did 4 times 6 and 4 times 3. Just like here, you could do 4 times the 6 and 4 times the 30. The only difference is, in the area model, order doesn't matter. Everybody just takes a turn. In the algorithm, order matters. Okay? So the order we go is we start with the ones on the bottom, then multiplies by the ones on top, and then moves to the left. But in the area model, I could do any of these 4 problems separately, and then I add them together. So that's the thing to know, that order matters when you... I'm sorry, I had a technical difficulty with the recording, and I'm not sure you heard the last thing I said. If you did, I apologize. But what I wanted to show you is that when you do the area model, you do 4 times 6 and 4 times 30. It doesn't matter which order you do. You can go 4 times 30, 4 times 6. You can do 20 times 30. Really, it doesn't matter the order when you do the area model, because in the end, you're just going to add them all up anyway. But here in the algorithm, the order does matter. You start with the ones, you multiply by the ones on top. Go back to the ones, multiply by the tens, and you move to the left. Okay, I'm sorry if I repeated myself. I'm just not sure if the video was recording before. But that's key. Order matters. Okay, go ahead and try this problem out. 532 times 248. Pause the video and give it a try. Okay, let's see how you did. So on the algorithm, remember, order matters. I start with the ones on the bottom, and then it takes a turn with the ones, then the tens, then the hundreds. It moves to the left. Here, it doesn't matter what order I start with in the area model. I could do that. I could do the ones times the tens times the hundreds. But it really doesn't matter. But here, it does. Okay? So 8 times 2 is 16. Carry that 10. 8 times 3 is 24 tens, plus that 10 is 25 tens. We carry those 2 over. 8 times 5 is 40, plus the 2, 42. Okay. Now I go to the tens, right? And just like with the 8 in the ones place, it takes a turn with the ones, with the tens, and then with the hundreds. Now here, I could do that, but it doesn't matter, but here it does. Now remember, I am in the tens place, so I have to add a 0 and get rid of what I carried before. 4 times 2 is 8. 4 times 3 is 12. I put the 2 here, carry the 1. 4 times 5 is 20, plus 1. 21, carry the 2, it drops down. Okay. Next. Okay, next I'm in the hundreds place. So I get rid of what I carried before. And now I have to add 2 zeros to show that I'm multiplying by 100. 2 times 2 is 4. 2 times 3 is 6. 2 times 5 is 10. So put the 0, carry the 1, it drops down. Then I add all of these suckers up. Okay, 6, 13, carry the 1. 3, 5, 9, 5, 10, 11, 1, 3, and 1. 131,936. So the key is to know that when you use the algorithm, order matters. You start with the ones, you move to the left. Also, for each new place, you add a 0, okay? Also, notice I'm using graph paper. It keeps my life straight. I've put graph paper out for you to use. You have your Smart Pals to use, but it really helps keep you organized. Let's do one more problem. Okay, 503 times 456. I would like you to pause the video and try this on your own. Okay, now I hope that went well for you, but I want to share a story. When I was doing this problem, I made 3 mistakes. I had to erase things and start over a couple of times. Using the algorithm gets confusing. It gets messy. So you just have to expect that. But the key is you just have to follow the rules. You start with the ones, and it takes a turn with everybody. Okay, then you go to the tens, takes a turn with everybody. Go to the hundreds, takes a turn with everybody. Add your zeros, and then you just have to constantly be checking your work. And you'll see that when I was doing it, I kept messing up the zeros. I did 6 times 0 and added a 1 and put a 7 at first. Now, 6 times 0 is 0. And you add the 1, it's 1. I just was making like a quick mental mistake. And again, I like to draw this over here just so you see that you can do the 6 times 3, just like you do in the algorithm. Everything's the same. Okay, I hope this video helped. Good job.